So in the previous three short lectures, I discussed the main concepts, I discussed the no-slip condition, and a brief history about fluid mechanics. This is the fourth lecture, and I'm still in chapter 1, which is about the introduction and basic concepts. So chapter 1, introduction and basic concepts. Again, I've done main concepts, I've done the no-slip condition, and a brief history. So this will be the main subject of this short lecture, which is classification of fluid flows. Main topic is classification of fluid flows. So I want to classify different types of flows. So the way I'm going to do this, I'm going to talk about three short movies, and then I will keep the others for you. So we can classify fluid flows by different methods, different classifications. So we can classify them as viscous versus inviscid. So viscous means viscosity is important. The effect of viscosity is important in the flow. Inviscid means the viscosity is not important. يعني flow لزج وغير لزج. Okay, تدفق لزج تدفق غير لزج. Compressible versus incompressible. Compressible means we can compress it. Incompressible, you cannot compress it. قابل للضغط وغير قابل للضغط. Laminar versus turbulent flow. Laminar يعني تدفق طبقي نفس الطبقات. Turbulent it has a lot of mixing and chaos. في فوضى وفي دوامات. بعدين we can have flow which is natural and forced flow. Natural يعني طبيعي. The flow is taking place by itself, by natural effects. Forced flow means we are doing something. We are putting force for the flow to take place. Steady versus unsteady. You know that steady, it is not changing with time. Unsteady means it is changing with time. It's different from time to time. Internal versus external. Internal, the flow is taking place inside walls, within closed place. External, it is taking place outside a closed place. So this is in a brief about them. Now I will show you the movies, and I will discuss with you these three: viscous versus inviscid, compressible versus incompressible, laminar versus turbulent, and the other three: natural versus forced, steady versus unsteady, internal versus external. I will keep them for you to watch uh, and comprehend. So let's start the first movie. The first classification is viscous versus inviscid. التدفق اللزج والتدفق الغير لزج. So now we will concentrate ونركز على the flow over a wing of an airplane. Okay, جناح الطائرة. So what you see here, those colors, the red color and the orange color, this shows, or those colors show the distribution of the wind speed. So whenever it is a higher speed, it is red in color. Whenever it is lower speed, it is orange or yellow. And we have here at the rear, at the back, في نهاية مؤخرة الجناح, we have the flap, and the flap is oscillating, يتحرك. And whatever you are seeing now, this animation, it is created by a computer, by a package. It is called CFD, Computational Fluid Dynamics. So here, very very close to the wing surface, here and there, قريب من السطح حق الwing, we have a very thin layer طبقة رقيقة. It is called boundary layer. Okay, الطبقة السطحية. So in the boundary layer, viscous forces, the forces that are caused by viscosity, they are important. They cannot be ignored. Okay, in this boundary layer, very thin layer. However, if we go away, as you can see those blue arrows, when you are away from the wing, from the boundary layer, viscous forces are not important. زين? Viscous forces are not important. However, the inertial forces are important. Inertial forces are the forces, let us say, they are governed by the velocity. اللي تسيطر عليها السرعة. So this is the outer inviscid flow region. Okay, this is our boundary region outside the boundary layer. This distinction due to So this was, let us say, a great contribution by this scientist panel. So this is the first movie or video clip, which is the distinction between viscous and inviscid. Now, this is the second distinction, which is we classify the flows as compressible versus incompressible. قابل للضغط أو غير قابل للضغط. Most liquid flows are incompressible. So most liquid flows are incompressible. Liquids are considered considered incompressible. غير قابلين للضغط. They'll keep the flow density constant when we solve the equations of motion. And if they are incompressible, then we keep the density constant when we are dealing with them in the equations. Also, to make our life simpler for gases, which are compressible, but at speeds much less than the speed of sound, also will deal with them as incompressible fluids. So this is an example, which is airflow around a toy airplane, or around a spinning football. طبعا this is an American football, which is different than the whatever the football we are using. On the other hand, if we are dealing with gases that are moving at high speeds, then they are very compressible. So you have seen the movie, and now you are seeing the simulation. And this bullet is emerging from the nozzle of the gun. قاعد تطلع من ماسورة البندقية. Okay? And what we have here, this red thing, is shock wave. Whenever we have an object that is moving faster than the speed of sound, they will have shock waves, and those shock waves were, let us say, created because of the high speed compression of the gas, which didn't happen when, for example, the other two examples, in the spinning football and in the uh, toy plane. Now, this is the third classification. Let us talk about it. Another way to classify flows. So this is the third way to classify the flow as laminar versus turbulent. Laminar flows. So laminar means the flow طبقي, flow in layers, less mixing. As you can see it here at the beginning of the flame. Okay, here, this region. So we have the flows smooth and ordered in layers. It is called laminar flow. So on the other hand, we have the turbulent flow. Turbulent flow when you have those, for example, a lot of mixing here, and when the inertial forces dominate viscous forces. لما تكون القوة اللي ناتجة من الحركة is مسيطرة dominating viscous forces القوة اللي جاية من الفيسكوسيتي من اللزوجة. And it happens at a higher location of the candelabres. So as he said, so turbulence will cause those eddies and swirls دوامات والفوضى اللي تشوفونها هذه فوق. So those eddies الدوامات هذه will cause a mixing in turbulent flow which wasn't there in the laminar flow. And usually dealing with turbulent flow is much more complicated because of the highly mixing. So now I come back to my slides. So as I've just told you that I talked about the viscous versus inviscid, compressible versus incompressible, laminar versus turbulent, and I will keep the rest, okay, which are natural versus forced, steady versus unsteady, and internal versus external. Those are easy also. You can watch them, please watch them and comprehend them. So this ends this section of the book. Actually, since this section will be discussed later in the, let us say, in the course, so for this section, you don't have to read it from the book. I will be satisfied if you watch the movies and comprehend them.